Hello everyone, welcome back. In today's video, we are going to learn about parallel and perpendicular lines. We'll learn the conditions for lines to be parallel and perpendicular. We are also going to solve problems based on both the conditions. So without wasting time any further, let's do some math. So first, for lines to be parallel and perpendicular. So let's check. When we say that the two lines are parallel, for example, let's say there's a Cartesian plane like this, and there are two lines. Let's say one line is passing like this and another line is passing like this, and let's say this is line L, this is line M, and these two lines are parallel. Or let's say this is L, this is P. So for two lines to be parallel, the general form of straight line equation, first of all, is y is equals to mx plus c. So we can say that the two lines are parallel when the gradient of those two lines are equal. So this is the condition for parallel lines. M1 will be equals to M2. This is in case of parallel lines. For perpendicular lines, let's say this is another Cartesian plane, and one line is like this and another line is passing like this, and they are perpendicular to each other. Let's say this is line X, or let's say this is line A and this is line B. They are perpendicular to each other. In this case, the gradient M1 multiplied by gradient M2 will give us -1 always, or this is also written as M2 is equals to -1 upon M1, negative reciprocal. So this is how we can identify that the two lines are either parallel or perpendicular, or vice versa. Okay, now based on this, we'll try to solve a few questions. So let's check. Question number 1, it says write down the equation of a line parallel to y equals to 3x plus 2. So the equation of a line is given to us, and we have to we have to write down another equation which should be parallel to this. So the condition is M1 is equals to M2 in case of parallel lines. So what do? We'll write another equation, y is equals to, with the same gradient 3, because here we have gradient as 3x plus, just change the equation. Instead of 2, we can write, let's say 3 or 4, anything. So this can be another equation with same gradient and different y-intercept. Let's try question number 2 now. It says write down the equation of a line parallel to this which passes through 0, 2. So we will have same axis, y equals to 1 upon 2 x plus passes through 0 and 2. So x component is 0 and y component is 5. It says write down the equation of the line parallel to this, a line which is parallel to this but passes through 0 and 2. Okay, so we can write y equals to mx plus c. Let's say c is not known to us, but we have the x and y component known to us, so we'll substitute it here. 2 is equals to 1 upon 2x0 plus c. So we can say that, so this whole term will become 0. C is equals to 2. That's how we cannot take c randomly here in this case, and we can write down y equals to half x plus 2. So this is the answer. This is 0, 2. This also means 0, 2. Let's say over here, the line will definitely pass from this point, 0, 2. So y-intercept will definitely be 2. Or this is the other way, in case if it is not 0, 2, if it's any other coordinate, we can use this method to write it down. Let's check another question, question number 3. It says write down the equation of line that is perpendicular to 3x plus 3. So our m1 is 3 and we have to find m2. So m2 will be minus 1 upon m1. So we can write it as m2 is equals to minus 1 upon 3. So the another equation will be y equals to minus 1 upon 3x plus anything. It says write down the equation of a line that is perpendicular to this line. So it can be anything. This is the answer. Question number 4, it says write down the equation of a line perpendicular to this line which passes through 0, 7. So simply m1 is equals to 1 upon 2. So m2 will be minus 1 upon m1. So we can write it as minus 1 upon 1 upon 2. So multiplied by 2. So we'll get m2 is equals to negative 2. And then we can write as y equals to minus 2 x plus 7 because this is 0, 7. Next question, question number 5. It says find the equation of a line parallel to 2y minus 3x plus 2 equals to 0 which passes through 0, 4. If you have reached till here, you can pause the video here and you can try to solve it by yourself, and then you can again come back and check the answer. It says find the equation of the line which is parallel to this line and which passes through 0, 4. So first rewrite the equation in the form of the general form of straight line equation, that is y equals to mx plus c. So we have 2y equals to 3x minus 2. So you can write it as y equals to 3 upon 2x minus 1. That means the gradient is 3 by 2. So another equation which is parallel to this is going to be 3 upon 2x, because in case of parallel the gradients are equal, 3 upon x, and instead of minus 1 this is going to be plus 4 because this is 0, 4. So it is going to be 0 and 4 over here. This is going to be the y-intercept 0, 4, which is parallel to this line 3 upon 2x minus 1. That means this line is somewhere passing from here with minus 1 as the y-intercept, 0, negative 1. Next question, it says find the equation of the line perpendicular to this line which passes through 0, 7. So first we'll write it down as y is equals to 2 upon 5x minus 4 by 5. So the gradient is 2 by 5. So m2 will be minus 1 upon m1. That means m2 is going to be minus 1 upon 2 upon 5. So multiplied by 5. That's how we get m2 as minus 5 by 2. So the equation will be y equals to minus 5 by 2x plus 7, and this is going to be the answer. Let's check one more question. Question number 7, it says a line passes through points 2, 1 and 5, 10. There is a line which passes through these 2 points. Let's say it is like this. This is 2, 1 and this is roughly 5, 10. It says find the equation of a line parallel to A. We have to find the equation of a line which is parallel to coordinate A. This is coordinate A. Not coordinate A. This is line A. Parallel to A that passes through this. So first we have to find the equation of this line. See, y is equals to mx plus c. So first we can find the gradient m. So gradient and m formula is y2 minus y1 upon x2 minus x1. So that is going to be 10 minus 1 upon 5 minus 2. So that's going to be 9 by 3. That is 3. Sorry, m. So gradient is 3 and we have to find the equation. So we can pick any coordinate. We can write it down as 1 equals to 3 times 2 plus c. So 1 minus 6 equals to c. So c equals to minus 5. That means the equation of the line is y equals to 3x minus 5. This is the equation of the line, and we have to find the equation of line that is parallel to A but passes through 2 comma 5. So gradient m2 going to be also 3. So y is equals to 3x plus c, but you have to find the value of c, but it passes through 2 comma 5. That means 5 is equals to 3 times 2 plus c. So c is going to be 5 minus 6, that is minus 1. So equation will be y is equals to 3x minus 1, and that's the answer. With this, I have a challenge question now, question number 8. So you can try this question and write your answers in the comment section, and we'll see how many of us gets the correct answer. With this, we are done with this video. If this was helpful to you, do subscribe the channel and like the video, and do share it with your friends so that they can also get help from this. Bye everyone. Thank you.